So let's talk about secrets. A key step in any deployment process is the injection of secrets, an area which often starts very simple and with time it can get complicated. We usually start with storing our secrets in an environment file in plain text and consumed directly by the application. Then we move to basic secret management features of platforms like GitHub or other part of your infrastructure. But as the team grows and the application scales, we start to see that this approach does not hold up. We start to see some familiar issues. We start to see that our secrets are scattered across the infrastructure and different repositories. We start to see that there is no historical log of what is happening, who is accessing the secrets, not only humans but also machines. And we also start to see that it's difficult to rotate the secrets. It becomes really an operational burden to do it. Often leading to not using really nice features that some applications offer because you don't want to introduce a new role or a new secret. And moreover, if there is some suspicious activity happening in one of your machines, your safest response is just to shut down everything. This hurts reliability, but luckily we can stop worrying about this stuff because there are some other solutions to this secret management problem. And this is by using a secret vault. You can use a secret vault from Hashicorp Vault or an OpenBao Vault. They solve this secret sprawl problem by centralizing the secret management. It offers also an audit trail for historical access and finite-grained access control. Just a little bit about OpenBao. OpenBao is a fork from HashiCorp Vault. You can think about it that it has a similar story as OpenTofu and Terraform, or Bulky and Redis. I'm just going to refer to both of them as just Vault for the rest of the talk. And they have been battle tested for more than 10 years, so they are well established in the industry. You can think about a Vault as just a secure application which is running on a remote server or cluster, and you communicate over HTTP via REST API. So the easiest way or the direct way to integrate an application with Vault is via an HTTP client. And that's what we call a Vault client. Vault does more than just storing static secrets. It can also help you to manage third-party secrets like database credentials. It can also be used other advanced features, like you can use it as a private certificate authority, leasing and renewing certificates for you, so it can also be integrated with your orchestrators to do some jobs. You can also do encryption as a service, manage identities, different methods of authentication, and there is multi-tenancy support. Many different languages have written an HTTP client for Vault. But what about Swift? Let me introduce today VaultCourier, which is a native Swift client for OpenBao and HashiCorp Vault. It is written in Swift 6 with the help of swift-openapi. It runs on Linux, Darwin, and also in Android. It can help you to manage third-party secrets from databases like Postgres and Bulky. So if you're using Postgres Neo and Bulky Swift, VaultCourier has you covered. I have added recently tracing support with Swift distributed tracing and some experimental configuration providers, which I'm going to talk in a bit. You might be maybe also trying to implement an HTTP client for a third-party service which has a big API, like the one of Vault. So I want to share some lessons learned during the development for the rest of the talk. The first lesson doesn't come as a surprise. You should be using Swift OpenAPI generator for building a HTTP client. It is not only about the generation of code, but it's about the enforced development that you get by spec-driven development. It's really good to develop it this way because the API is documented, and you also get some really nice things by using the swift-openapi generator, like it's transport agnostic, so it's going to run on different platforms, and you can also test it because you can also mock the client. And you will probably have to also write a thin layer around the generated code, because the generated code can change, and you don't want to break the public API that you're offering with your HTTP client. Nevertheless, it's going to reduce a lot of boilerplate. I also recommend to use package traits, because not all of your users are going to use all the endpoints that your client is trying to cover. So offer them ways to opt in the group of endpoints to reduce the binary size and the compilation time. In an ideal world, these third-party services will offer you an OpenAPI document, which is completed, but this is not the case most of the time. It was the case of Vault. Many response types were missing, so I have to write it myself. Then I learned that I found a treasure that actually there is a really nice Pkl package which could help me to write the specification. You can think about it like a template, like a form in which you are just filling up some things. It also helps you to learn about the structure of the document. This helps you to avoid stupid mistakes that you will do it if you just write it by hand directly into raw formats like JSON and YML. For those who don't know, Pkl is a model-safe configuration as a code language which renders into raw formats like JSON and YML. You can also write custom renderers. But if you want to deep dive into Pkl, I really recommend this talk from Dan Chow, Taming the Configuration Beast with Pkl. And you will learn a lot. I'm just going to mention that it helped me to modularize the specification, to write sub-clients. So what you see on the left is I'm spreading different paths from different sub-specifications. And I can just organize it how I want. And on the right, what you see is an example of how the OpenAPI document looks in Pkl. Besides helping with verification, you can also introduce objects in Pkl. And this allows you to stay dry during the writing process. So for instance, I have here this token common, which is a property schema. And I want to define an object which is almost the same, but with another property. You can do this in Pkl by a mechanism which is called amending, which looks like this. The third lesson, and with this I'm going to finish, is more about an experiment. I wanted to make it easier for people to access secrets from configuration. And I learned that you could do this with the Pkl bindings. So you could embed a Pkl program in your Swift program. And you could, with Pkl, you can read external resources, like secrets. So an example here is, you see an example of a very simple server configuration. I can also add references to external resources via URL schemas. I have two schemas here defined, Vault secrets and Vault database. And at runtime, they're going to be evaluated and passed to VaultCourier. What is happening under the hood is just taking this URL and transforming it into bytes. This experiment is guarded under a package trait, and a similar experiment has been carried out for Swift configuration, but that will be maybe a topic for another talk. If you are interested, check it out. I would like to get some feedback. I have written also some really nice fun tutorials with Vapor and Hummingbird. And if you want to learn about OpenBao, the guys from OpenBao are going to be tomorrow at this stand. Check it out.